Welcome to Web Security. And first of all, I want to congratulate you, welcome you to the class. I think we're going to have a lot of fun. We are going to, at least I'm going to try to make it as fun as I can. So let's get started. The number one thing I want to go over before we get started, okay, and I think let's just get this out of the way so we can just focus on hacking and having fun. Um, it's a little bit of my philosophy that you're gonna see as we go through the course, as well as some caveats that I think you should keep in mind as we go through this. The first thing I'm gonna do, and I'm going to impress upon you, is this information that you're gonna be learning in this course can be used for wrong and for good. Okay. One of the reasons why I want to teach this course, besides the fact that a lot of people have been asking for something like this from myself, is that as the web becomes more and more prevalent in each of our lives because of the devices we have, mobile, and all these things that are now coming in line with IoT and all that, I think it's more important than ever that we understand at least a little bit about security, even if you're not, trying to go into the field and become a penetration tester or anything like that, right? So even if you're not a pen tester, I think it's really important to understand the web. I think it's really important to understand security because you're dealing with these systems, and if you're not thinking about security, then you can understand that that's a risk. But beyond that, I do want to tell you that you are responsible for your own actions, okay? So I'm not going to tell you what you should or should not do with this information. I'm going to assume that you're going to do good things with it, okay? So with that being said, I'm going to push forward, and then we're going to just get right started in the course. Now, what are some of my philosophies about the web and about web security and bringing those two things together? I think more and more, and I think we saw a lot of it this year and maybe in the previous years because of Facebook and whatever. There's been a lot of data breaches, at least according to the news. Honestly, you can believe what you want, but here's the thing: the web, when you think about it, in the past 20 years, we have created a technology that has united more people than ever. Right? We have created technology that we can share information like never before, and this is information that no government and crosses, this goes across borders. This really gets to the heart of the matter of what it means to have a free society, and I think free information. So I think the first thing we need to remember about the web is what the web is supposed to be for. And the web is a place where the whole world can come and connect together, okay? And never before have we been able to do this, okay? So I think we should be very careful in the next few years. And this is something for you to think about. This is more on philosophy side of things, before we get right into the meat and potatoes of the course. But the web really is a remarkable thing that we have, and I think we should really be careful and take care of it, okay? Because it's going to be important in the coming years. And again, when you really think about it, everything that we've been able to share, you can pretty much go online and find any information that you're looking for, whether it's a video on how to create a house or how to tie a tie, or a grandparent seeing pictures of their grandchildren. So the web is really an amazing place. I don't know how else to say it, but I think we should really be careful. And I think to give that control over to any government agency or any other single entity without really thinking about what we're giving away, which is pretty much our right to communicate, I think that's a huge mistake, okay? So with that being said, let's get started into web security, and let's have some fun, okay? So the first thing, let's go over what's going to be included in the course, what are we going to cover, and what are some of the things that I want to get across to you in this course. The first thing is the attacker mindset, and this really goes to the matter of if most of us are web developers, and we're pretty much working with systems, or we're having to use code base that's going to be published on the web. And the truth is that if you're not thinking about web security when you're writing the system, then the system is probably vulnerable, right? So over here in this class, we're going to be going over some attacks, okay? And then we're also going to be going over some of the defenses for these attacks, because in order to defend against the attacks, we also have to talk about them, okay? So we're going to be, again, going over the attacks, and then we're going to be going over how to defend against them. We're also going to be going over what are the mindset that attackers are thinking about, and also what are the skills that they have and the skills that you need to have in order to defend against these attacks, okay? Now, why is security hard, especially on the web? Well, the first thing is there's a lot of buggy code out there, right? There's a lot of code that has been published over the years, and if you think about how the web was constructed, which is at the beginning it was just for academics, and it was for academics to be sharing code in universities. It was for to be sharing links, documents, but over the years we have really created something much bigger, and the web has evolved into something where we have videos, we have created full-fledged applications on top of this protocol, which is HTTP, and that wasn't really what it was meant for when it was created, right? So this has created some interesting engineering problems that some people have exploited in order to to take advantage of the system. Now, another reason why security is hard, especially in the web, is that social engineering is very effective. And this is true for any type of security, right? So the fact that there's so much information, okay, in one place, the fact that it has become such a large vector, meaning that right now there are more websites by a mile than there are applications, right? So because there's all this information on the web, and at the end of the day, there's people behind this information, pretty much it makes it vulnerable because social engineering and the fact that you can convince people or get information from people and then use that information on the web to gather more information, then that becomes kind of a self-fulfilling, like a cycle that that's pretty tough to guard against at every scenario. And the most obvious thing also is that there's a lot of money to be made, right? Information is power. And just the fact that, like I said, the web has pretty much the biggest repository of human knowledge in the world makes it kind of a huge target for exploiting, and there's a lot of money to be made. So because of this, security is really, really hard, especially when it comes to the web, where you don't have control over the full system, right? Now let's think about some of the vulnerabilities, right? When you think about the web, what are some of the vulnerabilities that you know of? Okay, there's ransomware. Okay, and we've seen a lot of this when it comes to cryptocurrency or systems being locked down, whole websites, and having to ask money in order to release a database or whatever. But ransomware, okay, ransomware, it's an attack surface that people have exploited, keyloggers, right? So if you can deploy some type of code on someone else's machine, you can maybe install a keylogger and then figure out username, passwords to their accounts, bank accounts, whatever it is. But keylogger is something else that we've seen on the web. Crypto mining, okay, and we've seen some of this stuff. I think it's not as big a deal as people make it seem, but I've seen attacks where people are installing just code that mines cryptocurrency, and that's an attack surface, I guess. DDoS, so denial of service. On the web, like I said, someone can lock down your computer or your website and deny you the service of it. If they have your password, if they have your information, then you're pretty much at the mercy of the attacker at that point. Also, there's spam. So someone can spam your service, someone can spam your server, and pretty much do whatever they want to do. And with spam, there's a lot of attacks that can come from that point of view. There's also blackmail, so camera hijacking, because the web over the years, we've tried to evolve it and make it a full-fledged platform. Developers have been asking and have been wanting to create better applications that are published on the web, and we don't have to, so that way we don't have to go through app development kind of processes, or be subjective to any platform. And like I said, the web is a place where we can all do this. So developers over time have been asking for more and more low-level APIs. So if you've worked with, maybe WebGL, or any of the Canvas APIs, or maybe the Camera API, or like WebRTC, all these things that, or even the file system, over time, these things have become more and more useful, okay, for building applications, and we have been wanting to put these applications online. So these APIs have become available, and through the browser, we've been able to use it as developers. But then this also opens up a lot of attacks that before, again, this is not something that the web was made for, so it creates kind of a vulnerability on that end. Also, there's a lot of potential for data theft. I don't know if you've heard where you are, but some banks have been some data breaches have happened in banks, and maybe some more personal data for political reasons, or anything along those lines can happen on the web or any place that there's a lot of information. And again, as the web becomes more and more the place where applications are hosted, then this is, I think, just going to keep on happening. And for that reason, that's more of a reason for us to learn a little bit about security and how we can defend against some of these attacks. So let's just go over some of the stats. And again, I just want to, we're just going over some of the overview stuff so we can get kind of an idea and get on the same page about what we're going to be learning about. But here's just some stats of number of records exposed. And these are just stats I pulled as of the year 2018. And over the years, you can see that it's been growing, So, more and more attacks are happening. But again, also the records exposed are less, or depending on, you can see a spike over here in 2016, 2017. But again, the main idea is that if we're not guarding against these things, then they're bound to happen, okay? And as you'll see in the class, there's a lot of vulnerabilities still. And as we tried to make the web backwards compatible, right? So there's still people that are using Internet Explorer 6, 5, whatever. And not everybody has computers that are up to date, right? Or as devices that are connected online in all parts of the world where everybody doesn't know how to use them. Then there's a lot of vulnerabilities on that end as well, right? So there is this tension between us wanting to put the information on the web so it's accessible, but at the same time secure the information so that only the right people, right, have access to it. And as we put medical records online, or if we put more of our personal information online, then then this tension continues, and it becomes more of an attack vector as time goes on. Okay, so what is web security? Okay, let's think about this for a minute. Okay. So if you get nothing else from this course, let's think about, this is probably the most important thing to understand. The same origin policy. The thing that the browser, and specifically the browser, when you open up a browser and you enter, the internet, for lack of a better term, the same origin policy, and what the browser is trying to do is it's trying to isolate sites from each other while running in the same browser, right? So if you know about processes and tasks, okay, and about how computers work, the browser is just a process, okay? And within this process, there is a lot of tasks, okay? And the task is the thing that allows us to navigate to different URLs, different websites, get data from the websites, load data, images, videos, text, whatever. And the thing is, when you open different tabs, or as you have different things open, for example, let's say you have your bank account open, and at the same time you have your Facebook account open, and maybe Spotify or Netflix or whatever else, you can see how these apps are operating in the same browser window, but they should not have access to each other's information. Okay, now this is where attacks can happen, and because again, you're dealing with different secure access levels, right? So one service, for example, let's say Facebook, you can upload pictures to Facebook. So Facebook, or music, or you can even write text or videos, and this needs access to your computer files. Okay, so on one end you have maybe services that need access to your file system. On the other end, you have services that have information about things you watch. On the other end, you have information about things you listen, and all this information, again, is different access levels to your own computer resources, as well as to your own personal resources that you have on your computer. So it's not just the processing resources that your computer has, but also the resources that you have put in your computer, right? So if someone gets access, for example, and can install a script on your computer, and through that script they can execute some type of code, which is done through JavaScript, then at that point, you can find yourself in a position where an attacker has complete access to your system. Okay, and again, if you're a web developer and you're creating websites and applications online, then this is something that you need to be aware of. Okay, but that's what essentially web security, and that's what we're going to be really talking about in this class. How do we create processes that are isolated and at the same time can protect the data integrity within their own processes? Okay, and that's probably the most important thing to understand out of the class. So let's continue here. So there are there's a few types of securities, right? So there's server app security. So the idea is that attackers can run arbitrary HTTP clients, and they can send anything to a server. So if we have the server client model, right, where a client can ask for resources from a server, right, and let's say you go into Amazon or Netflix or Facebook, right? When you enter your login credentials, then those websites actually send back from the server something that's personalized to you and your own history on the website. And your history will be different than someone else's history. But the fact of the matter is that any client can send to the server. Let's say you upload a picture, okay, and then let's say someone else visits your Facebook account. That picture is going to load for them as well. So now the whole thing, because we're sharing this information, if someone has some malicious code on that on that resource, and that resource gets loaded onto other computers, then those computers can be infected as well. Okay, so again, because of this, you want to be careful, and again, that's what makes it even more of a security risk on the web, because on the web there's really nothing stopping us from accessing pretty much any resource on the web. And since there is so much, anything can there's a lot of potential for something wrong to happen. Okay, there's also client app security. So prevent users from being attacked while using web apps locally. So as applications become more powerful and as computers become more powerful, we are seeing now that you can store a whole database on the browser, or you can execute some pretty powerful, even machine learning algorithms on the client side. Okay, so as computers become more powerful and as we start building more powerful applications, and these applications can live on the client fully and operate on the client fully, then these applications have access to client resources. Okay, and if they can then go ahead and communicate online and pass this information around, then again, this opens it up to a lot of security risk potential. And also, we have to think, how do we protect the user from social engineering? So because we don't have control of what the user might input, what the user might decide to load, and the users might actually have no malicious intent when they're maybe copying some code or a picture and then just pasting it on their website. If they got that picture from a website that's been infected, then that picture can infect many other websites without even the user knowing this. And again, if you are on a service that you're providing this type of functionality for your users, then you need to know these things. Okay, and also we're going to be talking about how ads and pretty much things that can follow you online and have this omnipresence, kind of as you visit more and more websites, and we want to deliver a more customized, okay, and a more tailored experience to each user. This also means that we need to track behavior across not just different websites, but across devices. So how do we balance that tension between being able to deliver a tailored experience while at the same time protecting the user privacy? Okay, and these are the things that these are still some of the stuff that's being worked on the web. But you can see how over time, these things have to be resolved somehow. You can, opt in to say, I don't want any tracking. I don't even want JavaScript to execute in my browser. But then you lose some of that functionality. And again, that's completely up to you as a personal user. But as a developer, you should definitely know that these things are out there, and you should definitely know how to defend against some of these things. So let's continue on. So think about it. Browsers, when we explain it this way, okay, and again, if we go back to how the web started, which was just simply, I think it was document sharing, right? That's what, when Netscape was created and when the World Wide Web was created, it was just academics trying to share documents and information from universities and things like that. Okay, over time it has evolved, but now we have put browsers in this position where they're trying to run arbitrary code, right? So it's JavaScript, and we have a JavaScript runtime on every single device, right? So everything that can pretty much load a browser has a JavaScript runtime. Okay, so right there on every single browser there is a server running. Okay, and this server can execute any arbitrary code. Okay, just like it would on any other server. Okay, and as the browsers evolve and as we get access to more and more low-level APIs, then we have more and more access to really low-level resources, right? So it's not just resources across the internet. We also have resources right there sitting on your computer. Okay, and again, this creates a huge how can I say this creates a huge risk for anyone developing applications or any user using applications themselves if they don't know what they're doing. Okay, so the web at this point has this extremely ambiguous goal to run any untrusted code securely on any device, right? So you, being the app developer, you can control what the user, essentially the runtime on their machine, you can control what they do, even when they load your website, even when they, and that's important for you to understand, right? So even when someone loads your own website on their browser, because they have a JavaScript runtime running, then they can do essentially anything to your website. And we're gonna be looking at some of those examples on cross-site scripting or injecting code. But that's pretty much that's pretty much what we're dealing with here. Okay, when we're talking about the web and running random, any type of code on any machine. Okay, and we also have on top of that this idea of different sites interacting in the same tab. So let's say you have an ad company. So let's say you go to like Facebook or something, right, or any other company, and then on the side you see some ads running. Well, those ads are actually that ad agency injected a piece of code on that website to run. And again, if that and those two sites are two completely different sites that are, one is loading resources from somewhere else, and then the other side is loading resources from another place, and these two resources are making up the whole site. But the thing is that that you want to think about is that these two websites are running code from completely different places, and you don't always have control of the code that's running, right? So that's the idea, right? And that kind of gives us a perspective of what we're dealing with. Again, as the web evolves more and more, we have more and more access to low-level features. And low-level features, I mean hardware access. So as computers become more and more powerful, and then mobile devices, and the fact that users can be mobile and have these really powerful computers kind of in the pockets of everyone, and Wi-Fi networks, and all these things, come together to create kind of a perfect storm for hackers and people that want to get access to information without permission, right? So that's something that you have to be thinking about. Okay, while at the same time we have this desire as developers to create the best experience for our users, right? So again, we get back to this notion of the tension between creating a really great experience for the user while at the same time preserving the user integrity for their information, and making sure that our applications do not cross those boundaries between protecting our users from anything that they themselves might do or someone else might do on their behalf, right? So all these things, when the web was being developed, none of these things were being thought of, and we're gonna see some of those things as we get into the course. That we can see that some of these APIs that we think about on the web are so outdated, but because we want to make sure that we're not breaking any of the older websites that are still using a lot of this code, but at the same time we want to create new APIs that give us more access in a more secure way. The web is kind of left in this limbo state of having really old, buggy code that has vulnerabilities, but we can't change. While at the same time, websites that are trying to push the boundaries of what's possible on the web, while not crossing any boundaries. So again, it's really an interesting scenario that we find ourselves when it comes to the web and to security. So let's the browser. When we think about the browsers, right, and the task that they're trying to provide is a really really difficult thing to do, right? Because even malicious sites, okay, any website, even good and bad websites, here's everything that that we have allowed them to do now, right? They can download content from anywhere, so anyone can pretty much write any website on the URL, and then you're downloading content, right? The fact that they're rendering even simple text from somewhere else, those resources are being rendered, and that code is being executed on your machine, okay, and on every user machine. So that's pretty much that's just the way the web works, right? That's just the way JavaScript works. So that's just kind of what we're working with, okay. We can also spawn worker processes, so we can, and with web services and service workers, now we can have code that's running on the background, right, and using even more resources that the user's even less aware of, right? So if you have these websites, and on mobile it's even more, even more of an issue, because some of these websites even know where you are in the world at all times, right? They have your information, they have everything about you, right? So you can literally be at the pool or at the beach in some remote island, okay, and just by the mere fact that you're connected to the internet, someone else can know this about you, right? And if they have your information or your users information, then again, you can just see how this is again, I honestly, one thing I want to make sure that we don't do is we do not want to create this fear mindset, okay? We're just trying to go over what the web is, okay? And these are just the facts. This is just these are great things that we all want, because we all want to deliver that great experience. But again, this great experience opens us up to these things that could happen, right? So again, you can opt out, live off the grid and go back to TP huts, or you can decide to live, in this world, and again, it's only going to keep moving forward, and I think we can get a great experience. But part of this great experience comes with a little understanding of what we're dealing with, okay. Also, because sites can cross communicate, any website can pretty much open up any sockets to a server and keep that socket open, right? So that connection can stay open for a long long time, essentially forever. If a site really gets if an attacker really gets access to a client's website or a user's website, and once the information that flows from there, or let's say someone logs into a public Wi-Fi, but then that Wi-Fi is actually an attacker spoofing some Wi-Fi or masking some Wi-Fi, then all the information that goes from your machine to another machine, all that communication can be intercepted, and someone can actually steal this information. And we've seen a lot of this stuff happen with not just attackers, but sometimes the attackers are people that you don't even expect, right? The governments have done this. We've seen this with the Snowden files. We've seen this with the Julian Assange stuff. And again, most people are unaware of how this happens, but this is just some of the stuff that could happen, right? This also the web. We can display media in huge number of formats. So you can open up PDF formats, you can open up video, MP4s, you can open up MP3s, you can display and play HTML. So there's a lot of protocols that the web has to pretty much account for, okay? Again, you can run custom code on the graphics processing unit, so someone can really get access and start controlling the hardware and the software that your computer runs on, right? And they can essentially run your computer out of RAM, out of they can do, if they have access and it's a malicious attack, they can pretty much control your whole system. And at that point, if someone doesn't know how to defend against this, then you're at the mercy of that person. And you can, again, this is this is just something to know, but you can also save and read data from file systems. So yeah, if someone can access your database or private files in your computer, if they gain access, this is something that could happen and you should be aware of. So again, these are some of the stuff that we're going to be covering in the course, and it's important for you to understand just a little bit of what we're going to be of the stuff we're dealing with when we're dealing with web security. So essentially, we come to this fork in the road where we have different visions of what the web was intended for and what we've actually gone ahead and done with the web, which is again completely unintended, but because it has been such a great platform for delivering information, over the years, I think this has been just the natural progression of things, and little by little, we have come to understand some of the stuff that that's good and some of the stuff that's not so good. So again, at the beginning, the web, all it was intended for was simple document viewing, right? It was just meant for text file and sending information. You have an IP address, and if someone, before even search engines, if you didn't know someone's IP address or where a resource was at, a website essentially, then you just didn't get there. But now, because of search engines, SEO, and all these things, things have become a lot more accessible. To the point that we've gone from simple document viewing to powerful application platforms. Okay, so the web today is a completely different thing than it was at the beginning. Okay, so the third goal of this course is learn how to architect secure systems. Okay, so now that we know what we're dealing with, okay, and now that we know a little bit of what we're going to be what we need to be tackling in order to understand what web security and how to really defend against all these things, this is how I'm planning to structure the course. Okay, so the part one is browser security model and the same origin policy. So in the part one of the course, we're going to talk about how the browser, okay, is structured, how the web, what actually is the browser, how the browser functions, and the security model that was implemented on the browsers and pretty much all browsers. So the standards that the specs have put out there for the browsers to implement. Okay, and we're also going to be talking about the same origin policy and why it's important when it comes to web security to follow this policy, and also how we can bypass the policy and how someone can attack this policy for cross-site scripting or injection attacks or any of the other attacks that we're going to be covering. Part two is client security. Okay, attacks and defenses. So we're going to be talking about how to secure data as data is being uploaded from the client and being uploaded to somewhere online. Okay, and then how is displayed on some other end. So again, if this data is coming from the client computer or or some code is running, okay, on a client's machine, how can that client be protected, especially if you're the web developer that's delivering the service or the experience of that client. On part three of the class, we're going to be talking about server security. And again, we're going to be covering the attacks. First and foremost, I'm going to be showing you what are going to be some of the attacks that someone can do. Okay, and then we're going to be going over some of the defenses to those attacks. And again, we're going to be covering some of the specs and some of the technology that have been coming online, such as authentication and TLS, also HTTPS, and a little bit into cryptography and how you can secure not just the client, but also when someone is making a request on your server, that you can guard against some of the attacks that can happen on the server side. And then the last part, we're going to be also, and this actually covers part 1, 2, and 3. We're going to be, as we cover the attacks and the defenses, we're going to be covering how to write secure code. Okay, so in the attacks, we're going to be actually going over live code, and I'm going to show you some of how to take advantage of vulnerable systems, and then we're going to be covering how to defend against these vulnerable systems so that you can actually go ahead and defend them for yourselves, and you can actually go help if you're interested in more depth and actually becoming a pen tester, how you can how you can become and do this yourself and actually make sure that no system is vulnerable and where to look for these vulnerabilities yourself. So the first thing, so now that we've covered essentially a little bit about the web, kind of what the web was intended for, and what it has evolved into, let's go into the three main pieces of what we're going to be dealing with when we come into web security, and what are going to be these things and why these things are important to understand. So the first thing is HTML. And again, I know this might be a review for some of you, and if it is, I'm sorry. It's just that you might have never heard of it from a security standpoint, and I think it will be enlightening for you to listen to this part of the course, even if it seems like a review. So again, I was able to pull up this image from back in the day. This was Netscape, and I think this kind of gives us an idea, right? Because sometimes we tend to forget exactly where the web started, but just remember this, okay? This is really what browsers were like, okay? And all they had was simple buttons or links that link to places, and just some like text and image. That's all you could do at the beginning in the web, right? Now it has evolved into a lot different. Now we can pretty much even have 3D experiences with things like Oculus and Quest. So the web has evolved from this to imagine having a full immersive experience like 3D personal computers, right? So I don't think anybody had that in mind when they created Netscape. Okay, maybe some people did, but I don't think we could have understood at that point the speed at which all that was going to come, and I think it's only going to progress even faster as we move forward. Okay, so again, HTML is really made up of these tags that the browser needs to understand, interpret, and then process and render. Okay, and that's where the code has to be executed at on the client side. So when someone requests some resources from the internet, this is pretty much what gets sent back to them from a server, and this is then the server goes ahead and gets this HTML, okay, and renders it to the browser. So let's from there, what we understand is it brings us to this natural conclusion: is how do we access things on the web? Okay, and we access them through these things called uniform resource locators. Okay, and these are URLs, and the URLs are made up of a few pieces. Okay, and let's go over each piece now so that we understand later on when we are accessing resources from the internet how these resources come, how we can access them, and then how the web actually goes ahead and renders them and processes them and interprets them. So the first piece is the HTTP or the S or any other protocol that you might be using. So there are different types of protocols. In this class, we're going to be talking about HTTP because that's the main protocol for the web, and this goes over the TCP protocol. But it's pretty much built, it's hypertext protocol, which is, again, if we look back to this to the screen, this is pretty much it, right? So it's the protocol that displays images, videos, text, that type of thing, right? So like that's what the web understands, and if you give it this document in this form, then it will render it in a way. All the browsers have implemented the standards in order to render the web the way that we see it today. Then the next thing is the host name. So the host name is pretty much because we have a DNS in the middle, and we have these really simple domain names. Later on, what happens behind the scenes, and we'll go over this in future courses, is that it gets translated into an IP address. But that's pretty much what the host name is. It's where this resource that you're trying to access lives, right? And the host name is pretty much a really simple way for people to pass around information and say, hey, here's where this resource that you want to get is at, right? In this case, we're using example.com, but you can just imagine facebook.com or any other thing. That's pretty much what we're saying when we're typing in the host name. Then the next thing, which is usually excluded from most from when we type in a URL, but it's always included implicitly when the actual search happens, which is the port number. And for most resources online, is port 80 if you're going through the regular URL. But again, a port number is just where on the server does the resource lives. And again, I think for most things online, is port 80 is the port that things live on. Then after that, anything that comes after the host name and the port, followed by a slash, that whole part becomes the path, right? So again, although things live on that host name, we can actually link to different pieces of that host name. So different parts of that host name, if we want to access a certain resource, that's not just the main homepage, right? And that's the path, right? And again, most of these things are done implicitly. So if you visit the homepage and you don't include the path, well, then the path is included for you by just a / and nothing after it, right? And that's just the path that you have access. So that would be the homepage or the index page. Then anything followed by a question mark is the query. So this is one way to pass around information from the client to the server, and we'll see when we submit forms and things like that. Forms take advantage of this aspect of the URL, and they can pass around again, sometimes it's something very simple like a user and a year. Sometimes it's the way we want to display the information. So if we're trying to sort it descending or ascending, we might pass the stuff within the URL so that we can then access it in a meaningful way from the server side. And then anything followed by a hashtag, this is called anchor tag. So because, and again, this can be used in videos, but also in websites. When you want to bring a user to a specific point within a URL, right? So within an HTML document, if you want to, let's say, bring a user to a certain piece of that document, maybe halfway through or something, then you can create an anchor tag and include it in the URL. And then what the URL will do is it will bring that person specifically to that point in the document that you specified. Okay, so, and this is pretty much how all URLs are constructed. Some of them have all these pieces, some of them have just some of the pieces. So everything pretty much needs to include the protocol, the host name, the port, and a path. Okay, and again, some of these things are included implicitly. So just because you didn't include the port or a protocol, behind the scenes it still gets included. But that's pretty much what everything needs. And then again, this is what a full uniform resource locator looks like, and this is how everything on the web is accessed. Okay, so now that's an important thing to keep in mind. And this, from this point, then we get to this point, which is what gets returned from the server. And again, as long as it's at the top level, it gets specified as a doc type HTML, so that way that the browser knows, hey, this is something that I can render. I understand this thing, and then the browser parses this information, and then it shows it and displays it to the user. So pretty much, an HTML document is made up of a lot of tags that the specs, so the committees have gone ahead and they've specified these tags that all browsers pretty much follow. And that's pretty much what every single HTML document is made up of, right? Image tags, video tags, audio tags, canvas tags, link tags, style tags, which again, these are going to be pretty important because this is how pretty much code is executed on the client side. So this is how JavaScript can be executed with link tags or script tags. This is how we can load in CSS tags. This is how we can load in image tags, and we're going to be looking at how these tags can become vectors for attacks. Okay, and how they can be exploited to run code that was not intended to be run, or code that accesses things or resources that was not intended to be accessed. Okay, and but pretty much that's pretty much how the document is made up. Right, so every HTML document is made up of tags, and the tags are, again, these are just resources. So every single video will have a source, an audio file will have a source, canvas won't have a source, but it'll access resources within the machine. An image tag will have a source, a link tag will have a source, a style tag will have a source, a script tag will have a source, or it will be inlined in the actual document. So with these tags, for example, we can include CSS. This can be external, so a link tag that has a reference through an href means that you can load in external files into this into any website, right? So not there is there are some things that could happen through CSS as a vector tag, but most of the attacks, most of the things that you will be encountering, we're going to be covering in the course, will be through JavaScript, because JavaScript, again, is that runtime, that execution runtime that's on every single device, pretty much anywhere in the world, right? So because every device has a browser, and every browser can run JavaScript, then this is pretty much the largest vector for attacks. Okay, and we can see how JavaScript can modify the HTML document. We can also load JavaScript externally, or we can inline it, as you see down here in the script, within the script tags. Okay, but in all honesty, JavaScript is a lot of fun. Okay, so yes, we are going to be covering how JavaScript, a lot of people like to rag on it, and a lot of people like to talk smack about JavaScript, but again, remember, JavaScript is the language of the web, right? So JavaScript is pretty much the #1 language that's executed around the world. So it's really, really important to understand JavaScript, and because of this, and because a lot of people still don't understand JavaScript completely, and it's misunderstood, and because it was a language that was written, I think, in 10 days when it was written, it does have some things that are that make it maybe not the best language when it comes to security. Maybe it's not like Haskell or something like that. That's a lot more thought of and super mathematical, and it's dynamic, and you can pass functions around as closure and all these things. So there's a lot of things that can go wrong in JavaScript, but it's a fun language. It's flexible. It gives us immediate feedback. It's also pre-installed on every device in the world. So again, it gives us the most flexibility, and it gives our applications the best chance of living without going through any app development process, right? So you don't have to go through a marketplace. You don't have to, ask permission. You can pretty much every single browser that's already installed can already run JavaScript. And because of this, pretty much any website that we can create, we can run, just host it online, and it'll run on any machine. And that's an incredible thing, right? That it really is. When you think about it, that is one of the most amazing things that we have ever created, and that's one of the things that I think we should protect. But again, it does open us up to some risk vulnerabilities. But again, just something that we have to deal with, and just something to note. It's also dev environment is pre-installed too, so it's easy to start writing code. So we're gonna see we have an inspector built right into every single browser, and because of this. One of the things that we need to understand is that we definitely cannot control what the users do, even when they load one of our websites into their machine, because at that point they have control of the website, and they can pretty much inject anything they want, or send something to our server, or any of these things that we have no control over. So once we have rendered on the client's machine some code, then at that point they pretty much have access, and it's running on their machine, so they also have access to a runtime. And again, this they can send some information to our server, and our server has to know how to handle all these things. So Node.js, on the other hand, is JavaScript that runs on the command line. Okay, so not just does JavaScript run on the client side, so not just is it installed on every single browser, as of a few years ago, on the scene, and now it's been a while already. But then came Node.js, and Node.js pretty much is JavaScript on the command line. So this is a backend language, language, kind of like a server-side language like Ruby or Python. Not that again I'm comparing JavaScript to any of those languages, but just to illustrate the concept is that JavaScript is a language that runs both on the client and on the server, right? So it's probably it's the only language, right, that the browser understands, and it's also a language that can run on the back end, right? So this, because of Node.js, this brought us built-in functionality for the file system. So through Node, and because it's a server-side language, we have access to, again, the file system. We have access to HTTP, DNS. We can open up sockets. We have crypto access. We have pretty much access to the full machine, right? So we have access to the full server through Node.js. And again, this makes JavaScript, again, very, very powerful. And the fact that it's running on every machine, again, just all the more powerful. And again, I think it's a lot of fun. I personally love JavaScript, so I'm a little biased, but this is what we're going to be covering. So I hope you're strapped in, because it's going to be fun. So stuff that belongs in scripting languages, but not in the browser, is what we can do with Node.js. And for this, Node.js is it's a great language, and I think everyone will do well to learn it. And we have a few courses, so you can if you want to learn a bit more about Node.js, then check out some of our other courses. Also, Node.js added a module system, so we can, just like we did in the browser, we can load resources externally. We can also execute binaries through Node.js. So again, this just made JavaScript even better. The fact that we can write it on the client and on the back end. And then when we talk about JavaScript, because it runs on the client, it runs on the server, and pretty much anyone can write a package and then publish it, and then some other server can load this package externally, and you don't always have control of who's loading the resources, who's publishing it, and who's running the code, or where it's running, what context. So because all these things are sort of arbitrary, and it's such a large vector space, JavaScript has a lot of APIs that we're going to be covering in the course. But these are the things that make it kind of a great space to do some hacking. Okay, so the JavaScript APIs can come from a few places. For example, they come from the JavaScript language specs. So this is what ECMAScript and the TC39 committee actually focuses on, and you can read up about any of the specs from JavaScript and the language itself. But then also when we execute JavaScript on the browser, then that comes with the whole set of APIs that are just browser contextualized, right? So so if you use jQuery or React, then that's JavaScript on the browser side, and then that JavaScript has access to things that's not necessarily accessible through the server. So, for example, we have access to mouse events, forms, submissions, and fetching APIs, and all these things that are not, are just part of the DOM, but not necessarily part of the server, right? And then when we go to Node.js, we have things that are part of the server, but not part of the DOM. Like, for example, creating servers. We can, create an HTTP client. We can access the file system. We can, do all these things that are part of server-side languages, but not part of client-side privileges. And examples of this are array. So an array is something we can use on both the client and the server. Document.create element. So an array is part of the JavaScript language itself, right? So that's part of the language as a whole. But then we have things like document.create element. That's just part of the DOM API, right? But then we have fs, the read file, and that's something we can do on the server side, but that's not something we can do on the client side, at least not explicitly. There are ways around this, but again, we have to exploit a piece of JavaScript that wasn't specifically made for that. And that is what we're going to be covering in this course. And we're going to be covering how to attack those vectors and then how to defend against those attacks. And again, these are some of the older browser APIs. And I want to end this part of the section here. And then we're going to be actually going over and getting started on some of the attacks on the browser side. So window.open, we can create pop-up windows. We can pretty much create things that are, for example, link. We can move the windows around. We can resize the windows. We can share in real time through WebRTC information. We can even get camera access, microphone access. I mean, it's really the Wild West when it comes to JavaScript, and in my opinion, it's a lot of fun, but it's also very risky and does open people up to a lot of risk if they don't know what they're doing. And again, because JavaScript is in every single device, you can kind of get an idea what we're going to be dealing with. So anyways, I hope you're excited about what we're about to get, about the journey we're about to take. I'm excited. So again, if we need to go over this introduction again, I know we covered a lot. We're going to be going kind of at a fast pace, but I want to cover a lot in this course so that you feel by the end of it that you understand the theory behind what we're talking about. You understand the practice, so how to, and then you understand the attacks and the defenses that I want to teach you. So that way you can actually go ahead and implement it. You can go ahead and get a job if you need to on as a pen tester, or if you want after this class, then you can take a more in-depth class into web security or just security as a whole. And I just hope it helps you out. Okay, so anyways, I'm excited, and I'll see you in the next class.